pressing record somehow to remember to record. All right, so we were talking about this, these distinctions and that little thing there. So I haven't got time to say everything we need to, but I at least got to write that out, kind of speak to you in the book. So as you go over it, you'll pick up these subtleties and you'll really be quite far ahead because we're doing, again, significant stuff. Let's take a look at this and build up this awareness and just trust. Your psychology is really important here. And it was true for me too. When I was, when I do in grad school, I do stuff, and we had this one book where professors often can't solve the problems. I'm like, great. But you have to tell yourself, okay, if people can do it, I can do it, and maybe I don't get the answer. I'm going to chip away. What do I know? What can I do? And eventually you start getting, I have that kind of hurdle in my head about music. It's like, oh yeah, you grew up doing music and you were doing this. I don't know if I could ever do that. And it's true, some people are crazy born good, but there's not that many of them. And usually it's because they were exposed to it very early. So, effort's our responsibility. Let's do this. So we got to have a mindset, I can do this. And I don't have to be perfect, but I can chip away. And the more I chip away, the more I'll get it. And with some stuff, it's pretty powerful and it really opens doors. So we did walking your dog last time. Let's do 18 is good. We'll get to that. Maybe we'll see how much I chat. I'm going to do number 8's good. Where's my shopping? Oh, maybe it's just 4. Yeah, number 4, grocery shopping. Okay. Now, this is how you do physics exams and physics homework, and it's how you get good. Generally, physics exams take stuff kind of like what you've seen, but they change it. So if you memorize the solution, it's not going to help you. You're going to get lost fast. If you memorize how to approach it, you're going to get into it. Just stop me anytime you've got a question and anytime you can't see something. It's probably a little better. Oh, that's that. I think I'll do this. Okay, grocery shopping. Hopefully you've got that in front of you. I'm going to read it and do it. So first we do a quick read. That's a little improvement, hopefully. We'll see if you can see it. Light on there. There. Let's see about some diffused light. Not very much. That goes there. All right, let's give it a shot with my lighting. So I'm going to read this and do it. Do you ever get the feeling you're being watched? Okay. You're in a long shopping aisle. Now, sometimes you have to ask a question during an exam, etc., because I might not say some things. So it's like, oh, is this true or not? I mean, is the shopping aisle straight? Well, usually it is. So I meant that to be a straight forward and backward thing. Now, you can go sideways or up and down. Having read this, I know I need a little space, plus I got this board that goes like this. So I'm going to here's my long shopping aisle. I'm not going to draw anything too fancy, but I'm going to do this. Okay. And I read through it once. Now I'm going to go through it slowly. So I get this sense of the layout. And sometimes you got to redraw it because you go, oh, shoot, I'm going off the page. Starting at the pasta, of course, you walk 3 meters and arrive at the sauce 3.1 seconds later. Okay. So I need to start somewhere. And I kind of read it, so I kind of know how that's going to, I'm going to start here, and I'm going to just draw, you know, don't draw anything too, squares and rectangles and circles are fine. So that's state one, or I can put state one here. And I'm going to put P for pasta, because there's a lot of puzzle pieces. Don't do anything in your head. Even if you can, the stuff you can do in your head, you're training to write it down. Okay. Starting at the pasta, boom, I started at the pasta. You walk 3.0 meters and arrive at the sauce. Now, it doesn't say which way. It doesn't matter here. So I'm going to walk 3 meters. Doesn't matter. This is not vertical. You're walking horizontal, but I draw it like this. So let's do this. Let me go like this. And I'm going to do 3 long steps. So I'm going to go 1, 2, 3, 4, 5, whatever. Then 1, 2, 3, 4, 5, 6, whatever. And those are meters. I could just do a straight line. You don't need to do it like this. It's probably more than you need, but that's fine. Okay. You walk 3 meters and arrive. And we got to get this down. We got to turn the words into a picture and the picture into algebra. We do not, you can't get away with just plugging into equations. You will be sunk. Okay. 3 meters. 1, 2, 3. Ha! I'm at the sauce. If you want, you can write state 2. Now, what do I know here? Oh, that's right, I'm doing motion. So I got time. I got delta t, or interval of time. I got position and delta x, which is displacement. I got velocity and I got acceleration. Oh, always on these diagrams, you have states, 1, 2, 3, 4, where you pause the video. You have coordinates. You have to choose which way is plus, doesn't matter, just choose and be consistent. And you have to show the variables. That's the key. And books are never explicit about that yet. So I'm going to go ahead, it makes sense. I'm just going to call this T1 is 0. I'm going to call it T pasta, but I want to do 1, 2, 3. And I'm going to call that X1 is 0. And by the way, I think I'm going to go ahead and choose, it doesn't matter. I'm going to choose this to be the plus X direction, and I'm going to put my units in parentheses next to it. Now in math, they often don't do this, but we're applying math to this. So I want to show that because I could forget. And missing negative signs is it's a constant source of mistakes, and it eats up time and it makes you frustrated and feel like I can't do this. States, variables, coordinates. All right, cool. So then I go up here and it says you walk 3 meters and arrive at the sauce. So I arrive at the sauce 3.1 seconds, always units, later. So really that's delta t is 3.1, but I started at 0, fine. Delta x was 3.0, but I started at 0, so I'm going to go x2 is, did I go in the plus or minus direction?
Plus.
Plus, right? You can see it. Why? Because I chose that. If I flipped it, that'd have to be negative. As long as everything's consistent, you'll get the right answer. Here we go. Plus 3. This is wrong. What's wrong with that? Anybody? What's wrong with that?
3.0?
Should it be 0.0? That is where real work is done. right? This is an exercise. It's true. Could you get away with 3? Probably. No one cares. But this is where real work is done, and that really matters. Okay, good, cool. You study the sauce choices, you pick one, and you head 5.0 meters back the other way to the sourdough bread. That sounds like a good decision. All right, let's go back to bread. Blue for 5 meters the other way. So that means long steps. 1, 2, 3, 4, 5. And I am at state 3. I am at the bread and state 3, if you will. Okay. So what is equal to 5? What's 5 meters? What is equal to 5.0 meters? How would I write that as a algebra variable? Give you a hint. You got
distance.
You got t, you got delta, oops, you got delta t, you got x, you got delta x, you got v, you got delta v if you want, you got a. Yeah, what is it?
Distance.
It is distance and it's displacement. So you went 5.0, but you, okay, hold on. You definitely walked 5.0, right? Assuming we're just going straight. So I could do distance. In a lot of our equations, we do displacement. So if I do this, tell me what's wrong. Delta x 2 to 3. What's wrong with that equation? Or that statement? What's wrong with this? I'm going 2 to 3. What's wrong? This is just your training your awareness. It's the little things that get you. Are you going in the plus or the minus direction?
It should be negative.
It should be negative, right? Those are the things that, and it's like, no, you're not lost, but you will always be frustrated unless you keep track of these things. So that should be negative. Okay, now I can just look at this and I can say, well, x2 is equal to, so Jacob, this is kind of to your question too. I can just look at this and I can go, well, if this is 0, I'm at 2, not 2, 2.0 meters. What's wrong with that?
Negative.
Yeah, and it should be 3. And that's why you write things down. You're always checking yourself. You're going, wait, did I do that right? It should be negative. So you've got to pay attention to pluses and minuses. All right, so I can see that, right? Here. Now, if you want, you could say, all right, delta x, the displacement is x3 minus x2 is negative 5.0 meters. Just write it. Get used to the units. Just go ahead and don't shortcut it. Don't shortcut your training. x2 was 3, so that's x3 minus 3.0 meters equals minus 5.0 meters. If I add 3 to both sides, I get minus 2.0 meters. Yes, it's exactly what I see. This is how I do it algebraically. But I can also just see it because my picture's clear. And that's what we're doing. We're connecting words, pictures, algebra, graphs, and equations. And sometimes it is redundant. I didn't need to do that. I can see that I'm at -2. Now, 5.0 meters back the other way to the sourdough, you arrive at the bread 9.3 seconds after you started at the pasta. So what's equal to 9.3 seconds? There's 2 answers. You You guys are imagining this as a video, right? You go up here, you choose a sauce, you come back here. Oop, no. Wait, yeah, pasta, sauce, bread. All right, got it. What's 9.3 seconds?
The time from pasta
Time.
to bread.
Yeah, you could say it's delta t from 1 to 3, from here to here. But since you started at 0, you could also just say it's t. So it just depends. But you have to just realize you're looking for this. That's all you're looking for. And you just need training because it is a lot. You know, it's easy to get confused. Professors have been doing it long enough, they can make you feel stupid, like, whoa, well, wait a minute, I'm just trying to get used to this. 9.3 seconds. I know that's a time, seconds, cool. Stop me if you don't. All right, cool. Now, I know that, I can see delta x from 2 to 3. What's delta x from 1 to 3? What's the displacement from 1 to 3?
-2.
-2. You can see it, right? But the
Yeah.
distance is 1, 2, 3, 4, 5, 6, 7, 8. Right? That's the distance. The movie runs like this. The movie doesn't go like this. It goes up here and here. And so the displacement delta x is -2. The distance, you got to add all that up. And it's not really an equation. You know, you can make something up, but. And that's tricky, but once you get that, oh man, we keep getting things clear for you so that they're not in your way. And you could imagine that classmates that don't take this, they're gonna be stuck on a lot of this. Okay, cool. All right, we got bread. You pick an artisan loaf and keep going the same direction, another 2 meters to the tortillas. We were gonna do tortillas the other night. Pulled out the tortillas. It's fun to do them. Got a maker. It's fun to make your own tortillas. It's really easy, actually. But they were moldy, so I'll use green for tortillas. It's like, oh man. You go 2 meters in the same direction. So I'm going to go 4. I'm going to go tortillas, state 4. What's equal to 2 meters? I think it was great.
Change in x
It just
from 3 to 4.
Draco, did you say distance?
that was me.
Yeah. Who's? Yeah. So why'd you say distance?
Because it's positive, right? So
That's right. If I'm going to say something is 2, distance is definitely 2 if you go straight. If I wanted to say what the delta x is, because often my equations are going to be there, from 3 to 4, what's that equal to? That's plus?
-2.
Negative. It matters. Nothing will work if you get that wrong. And it'll be frustrating, and that's silly because you got this. Okay, cool. So, in fact, I know what x, I can see what x4 is. What's x4 equal to?
-4.0.
-4 because again, I've always got, it's why you got to do this because it really is. It's too much to do in your head. And if you do that, you're faster. You're always checking things. You're always checking things. There's some study I remember about reading speed, and physicists have the slowest reading speed. I know when I got out of grad school and we got out of doing some stuff, I literally had to train my eyes to go left to right because physics trained me to go like this. Like you do with puzzle pieces. You're looking for puzzle pieces. You're not going like this with your puzzle pieces. It's exactly the same. So you're always checking things, cross-checking, because I hate when I make a mistake and then it takes me an hour or 10 hours I learn a lot from those mistakes because then you go back and check. What does it say about time? Oh, taking only 1.4 seconds to get from the bread. See, I can look up here to the tortillas. What's 1.4 seconds then?
Time.
What time? To go
The
from,
delta from 3 to 4.
right. See, and we're translating into a language of math. This is something that is almost completely ignored in your textbooks. And it actually is the biggest hurdle. So that's one of my missions, is to get people to realize that. Delta T 3 to 4. Now I already knew that 3 was 9.3. I'm going to go another, it's going to take me another one. So I could even figure out that T4 is equal to 10.7 seconds. I can barely see that. You might go, wait a minute. This has 2 sig figs, 2 sig figs, 3 sig figs. Again, we're not going to be hyper picky about that. Just having some awareness will be great. But I will say that we're adding. And when you're adding, you just look at the less decimal places. This is good to 0.1 seconds. This is good to 0.1 seconds. I'm going to keep this one good to 0.1. So that's actually correct. A lot of little things that just overwhelm you at the beginning of the session. When we finish, guys, when we finish 3, 4, and 5, we'll see how far we get into 5. You have all the main analysis tools. Most, there's some little things here and there, but you have the core of what you need for all of the physics problems. So it's substantial. Okay, you're at the tortillas and you say, aha, enchiladas for Tuesday. It always makes me hungry. I love enchiladas. Okay, you run back to the sauces. Oh, I can see on my picture, it's so much easier now. Same location as before, and you grab the sauce needed for dinner on Tuesday. So watch this. I've got a movie. I go 1 to 2 to 3 to 4 to 5. I don't know what T5 is. I can see X5. I know what X5 is. It's equal to X2 plus 3.0 meters. I can see that. From starting at the pasta to ending at the enchilada sauce took a total of 18.8 seconds. Since I started at 0, it's not true if I don't start. I got to look at it. Don't just put in numbers hoping. Make sure. I always say you're going to bet $1,000. Oh my goodness. That's part A. That's physics. You can manipulate the algebra. That's the hard part. That's the missing part. And unwittingly, physics professors, because they have so little time to do so much, and textbooks teach you, they almost tell you, go to the equations, go to the equations. But even if I were to go to the equation, while I turn around to the board, I would have done this in my head, some of it. You know, I've done it a while. You do it just as fast as me. Anyway. And now, if I want average speed from 1 to 2, I go, well, what's the distance? If I want average velocity, what's the displacement? Oh, same thing. If I want to go 1 to 3, the distance I got to count up. The displacement is -2. You can do it on your picture, and you can do it using your equations. We're connecting those. That's the point. Any questions? That's a motion diagram. It's basically a video that's been paused at different places. Now, if you didn't know that when you go from pasta to sauce, if you didn't know what happened, you couldn't do distance. I mean, if I went up here and then, oh, wait a minute. Oh, wait, no, wait. All that's distance. So to do distance, you'd have to know that you went straight. You could pause, you could stop, it doesn't matter, but you can't go backwards because that adds distance. But independent of knowing that, you can sure get delta x. You can sure get displacement. Watch out for that. That's why we put this on our board. When you do force analysis, I show you how to really train. It's a training. So you just got to put in the effort. But you know, I have to create the training because I know the stuff. I'm looking for someone good to create the training for my music. You know, I got something pretty good. Could be better, but it's good. I need a guide. Questions? Just take a little pause. Yeah. All right, cool. All right, so, and you could have drawn it this way. It doesn't, you know, none of that matters. You could have made plus down and started going. That doesn't matter. Yeah, question, someone. Jacob?
Could you write T3 as 12.4 seconds? Because it's, if you include the time, because you're going from instance 1 to 2, wouldn't you include the 3.1 seconds going from 2 to 1?
This is a really good question. And this is where you guys are gonna really benefit by doing what you're doing. And you're gonna mess up, because I mess up on, you know, okay, I'm just gonna keep messing up until but I'm gonna try. I'm gonna put that effort in. Let me read the problem and see, because I could have messed up. Sometimes you think you're reading it, but in your head you're filling it in. Okay, let's see what it says. Okay, you start from the pasta, you go to the sauce. You pick one. You head 5.0 meters back. So you went this way, you're going the other way to the sourdough. You arrive at the bread 9.3 seconds. And then it says, after you started at the pasta. So that's after this, the 9.3. So after after starting at the pasta, you arrived 9.3 seconds, and that's 9.3. If it was 9.3 after the sauce, then you would add it. Make sense?
No, I'm not really following.
That's okay. Good. I'm glad. People like you learn the fastest. You got to ask those questions and not be afraid to do it. If I start here at time 0, start my stopwatch. Stopwatch, I'm walking up here, whatever it says, 3.1. Then I hang out, whatever. And then I go, I don't know what I do over there. And then I head back here. And this says, after I started my stopwatch, after I was at the pasta, it has taken 9.3 total seconds.
Oh.
After you started at the pasta. Those are the little things, and you're going to get tripped up. But the more practice you have interpreting the words, drawing the picture, and putting into the symbols, the less you'll get tripped up. You still might.
I thought it was 9.3 seconds from 1 to 3.
It is from 1 to 3, but that includes.
Yeah, I thought it was like the displacement, like the change in.
Yeah. Good. And this is what learning is. Like you have this preconception, or you get some confusion. Why? Because it's all new, you know, and that's good. Cool. Excellent. Because and it really pays to put whatever time is. You got to make progress. So whatever time that takes you, to get that stuff straight. Don't just let it go. And when you do, you're going to get faster and faster. Cool. Now, All right. Let's do graphing. We got words. We got a video. We got pause. We got super, this is a, books are not this careful with notation. They should be, because it really helps you. Coordinates. Got some equations. You know how to do average speed. Once you have this, you can figure out average speed and average velocity once you get that straight. Once certain things get easier, then it opens you up to understand more. Now we're going to do graphs. Graphs are extremely useful no matter what STEM field you go into. And there is a way to learn graphs, and you might learn a new graph and it takes you a while to get used to the meaning. What does it mean? What's this graph telling me? But and this is something that is rarely taught, not really taught explicitly like this. I was at campus on Tuesday. And here's the new Science Center. That's the way it looks now. This is the way it's going to look. It's gonna be so cool. But this is they got the second floor in, third floor is gonna be up there. Observation deck, it's gonna be so cool. And they were out there with their drawings. And I'm hoping they get it right. And you can bet they check each other because it's easy to make a mistake. So you always want, it's like, no, we gotta get this right, better not mess this up. So it is coming together. I'm psyched about that.
So that's it. I went up to the campus too, and I looked at it. I was like, "What is that?" The last time I seen that area, there was nothing.
I know.
That much progress.
You know, go COVID, man. So I don't mean to be too flippant about that, but you know, it has let them work a lot faster. They don't have to worry about noise. They don't have to worry about people, timing. So they're ahead of schedule. It's just like they're supposed to be done next summer. I'm hoping it'll be, I don't know, May, so we can actually do the move-in in the summer. Maybe start classes in the fall. We'll see. If you
Can't
leave,
wait
you
to
gotta
see
come
that.
back. What's that?
Can't wait to see that as I'm walking to class.
Oh man, it's gonna. That's the final like rebuild of Contra Costa. It used to look like a dilapidated high school, and it was, you know, for a lot of us, we're there because we like the community. This is where we want to be, and it's great. Now we have this for the community and something to be proud of. And our programs are strong. So let me show you this. I'm gonna do something a little different. See how you like this. I want to talk about graphs. You can graph anything, any two quantities that we can relate. You can do more than that too. But so I'm gonna go like this. I'm gonna make a graph. And a lot of times in math, let me do colors. A lot of times in math, it'll look something like this. And if this axis is time, often we started at 0, but you can interpret it various ways. But it doesn't have to be time. It could be anything, and it could have a negative value, so whatever. Now in physics, not all of us, but most of us like to put an arrow. That's going that way. And then I have to look at what it means. And again, there's a lot of words, and tying the words to the thing and tying it all together just takes multiple passes. There's nothing wrong with you. This is profound stuff, but you can get it. So I'm going to call these axes right now. I'm going to call this axis this, my new thing. And I'm going to call that axis that. This is going to be kind of short, but we're going to apply it. Okay. You could have pressure of a gas and volume of a gas. You could have position versus time, velocity versus time, acceleration versus time. That's what we do for kinematics, and that's what we're going to work on. But you could graph lots and lots of things: force versus position, force over time, lots of different graphs. In biology, every field uses graphs. Okay. What do you need to understand a graph? What do you need to spend a little time studying? Well, you need to study the meaning of three things primarily. You can get more subtle than this, but these are the main things. And if you train your mind to not just to skip a step, but to go kind of slowly through it, and then you get faster and faster. We have points on the graph. And any point on the graph tells us the value of this at
podcast.
The value of that. Now hold on, because this means that I could show you any graph and you could tell, I could say, what does that point mean? You'd say, well, it means that I have this value when I have that value. So you always know. You go, well, what does that mean? Well, you look at what this and that are, and you also look at the units. The units are always, it takes a while sometimes for people, but when they get how amazing paying attention to the units is, it's your secret little helper, your teacher. So that's easy. I mean, you just look this at that. That's what this graph means. Whatever those values are. Next thing you can look at, as you know, but I'll show you, it's going to get a little tricky if you just go back to this and slowly go. So you got slope. And you can have slope at a point, or you can have slope between points. And to do this, you know the equation. You look at the change, how much you change this, divided by how much you change that. Rise over run. The change in this over the change in that. And the more you do it, the more fluent you are with whatever graph it is. And you can look at the units and whatever the units are. And we'll talk about that in a minute. Could be meters per second. Could be meters per second per second. It'll tell you. It'll tell you right there. And you can do that at a point. You can take a derivative of the slope or do whatever, find it at a point in another way. It's still going to have the same meaning just by looking at those units. And finally, and I say this here, and then I give you tons of little exercises. You don't have to memorize it all, but try to retain some. But actually doing it thoughtfully will prepare you. Unbelievable. If you're in, well, either Professor Liu for Physics 120 or Wong for 130 will be thrilled. They are very nice and very committed to you, but they do have standards. The other thing is the graphical area. People often just say area. It drives me crazy. I say that in the book. Graphical area. In other words, if I have this graph, I'm going to have the area between my curve and that axis. I mean, this is the whole story. Above that axis, I should capitalize that. Above that axis is positive. So we call this area positive. Let me go out here. And we would call this area below it negative. And we're almost done with the essence of all graphs. Now, watch this. This will be your second week lab. Studying simple examples will build you up and you'll understand what the more complicated situation is. So I could go here. I could go here. I could.
Can you move your camera up?
Yes, thank you. Now this is an idealized picture because there's really no way to instantly change. We say in physics, there's no sharp corners in physics. But they could be approximate, so usually it's random, but this is easier to do. So in physics classes, when you're starting, you know, we keep the examples simpler to calculate, but sometimes that makes it confusing. Okay, watch this. If I want to do the graphical area here, if I want to know what the area is in here, then I take this value times, not that value, but the change in that value. That's a nice rectangle. So it's just this times the change in that. And here it's a triangle, so it'd be 1/2 of the rectangle, 1/2 of this times the change in that. And so you'll see a lot of graphs like that. So they're kind of easy to do. We make them so it's rectangles and triangles. What does it mean? Well, let's see. Now this would be positive. Right? This would be positive. This would be negative. I don't know what it means because I don't know what this and that are. But let me show you.
I had a question.
Yeah.
How does graphical area relate to displacement?
Ha. Hold on. We're very close.
Okay.
Yeah, great. In fact, yeah, we're so close. Let me finish this and let's tie it to position versus time, velocity versus time, acceleration versus time. That you will master a lot of your physics. You get a few other graphs, you start getting into energy, there's some other stuff. But then every new graph you go, okay, let me look at the units. What is this telling me? I got to spend a little time with it so I can figure it out. But I got it. How do I calculate it? I do this. Just think of a rectangle. The calculation is the value of this times the change in the value of that. And since I might have different pieces of it, I need to add that up. That's the Greek sigma or S for summation. The Roman S is like this. That's what the integral sign is, a smooth summation. With calculus, this would be an integral, and this is a derivative. That's all it is. You just learn a lot of tricks for doing the same thing, but this is the essence of calculus, which I go to in the short chapter 6. Now, what does it mean? What's the point? I don't know until we apply it, like Jacob was saying. So, but I can tell you this, if I know the units of this and the units of that, then whatever it means has the units of this times that. And this has the units of this divided by that. And this has the units of this at that. That's it. This is it. This and that. And then you just got to apply. But you've got the general idea. There's nothing beyond you. You just need familiarity. And now we're going to do that and this. Any questions? Good. You got it, right? I mean, you could do this. You might ask, now you might get in your way. Yeah, and I used to have a problem, a mental block, where I wanted to know everything and understand everything. And so that meant I'd go, well, why? Why is it like that? Or with music, why is the major scale 7 notes? Why do you do it like that? Why do you do whole, half, all? Why do you do that? And someone just needed to slap me and say, you'll learn. Give me a second. You got to play with it a little bit and figure it out. You know, you got to play with something to figure it out. So you got to trust your guide, you know, and you'll figure it out. So give it time. I really, when I finally got over a few things, it helped. Because I'd always, like I had a relativity class, my first upper division relativity for 2 weeks. And I thought, oh, this is really cool. This is cool. I couldn't do anything. And I kept arguing with Einstein, basically. And then it was like, okay, wait a minute. I learned this stuff pretty well, and I would tutor people, and I was really into it. So I get this intuition. And then you go to relativity, and the game has changed. And so you do relativity, it doesn't make sense. And so I had to say, okay, A, they might know more than me, maybe. And B, let me treat this like a game that has its own rules, and those rules have been shown to work in experiments. I wish someone had said that to me. I had a great professor, but he didn't say. And so let me just use those rules, and I'll play by the rules, but they're not intuitive anymore. So I encourage you to do that as you learn this stuff. When we're talking about motion, we can do a motion diagram like the grocery store, or we can do position versus time, velocity versus time, acceleration versus time. You're getting so used to it by doing stuff. Sitting there and reading it over and over will get you almost nothing. You have to do exercises. You could read music theory, oh my God, and you'd have nothing. It's like, okay, can you play Kumbaya? No. All right. Then why did you do it? You've got to practice. Now, usually we start the clock and we look at positive times. This is acceleration. Now we can use whatever units, but I'm going to say meters per second, or meters per second squared. How many meters per second do I pick up or lose every second? This is my velocity, which shows a plus or minus direction and how fast. Ooh, I should do that. See the second, the PM, I remember to do a couple things. And I need this one. Okay, and I've chosen, I think, something that in our limited time you get the maximum value. So I'm going to say X. I'll say meters. We don't have to use meters, but we do that a lot in physics books. Fine. T seconds. Use whatever you want. Now, we're going to think about a motion. I'm going to do a couple of things. Suppose, I'm going to graph this. Your second lab will probably be in the lab because it's really hard to do labs remotely. And the one that we do is this, and we walk in front of this motion detector that sends out sound, bounces off of us. It can tell how far away we are. And then it can calculate the change, the displacements, velocity. And it can graph this for us walking in front of it back and forth. It's cool. If you get this, that one won't be hard, but anybody not taking this class will struggle a bit. Okay. What would this graph mean? What would a graph like this, if I give you that graph, what motion am I graphing? I just go right along it.
Standing still.
Standing still where? Someone else. Now, Jacob, this is great. I appreciate it. Someone else jump in.
Same direction.
Am I moving?
Same direction you're moving.
I don't know. Jacob said we're standing still. So we got to sort that out. And that's okay. Jumping in is all that matters. Not making a mistake doesn't matter. Jumping in.
Standing still as time increases.
Time's going on, but physically I would be standing. What would be my position? What would my position be?
0.
0, right? Okay, now that you can see that, so that means, so I'm going to draw a square for the object. But the graph would go like this because it would say at this time, I'm still at 0. At this time, I'm still at 0. At this time, I'm still at 0. What would the graph look like if you were at 2 meters and standing still?
It'd be
Like
the same 2 meters.
Right. Be up here, right?
Yeah.
But physically, you'd just be standing there because it's like the shopping aisle. But the graph would go like this because you're standing still. What if you were at -4 meters? Right? Because you just be standing there, right? Like you are now. Now you're sitting. What would the velocity be in each of these cases? What's my velocity right now?
0.
0. Now, like I said, the trick is there's a lot of ways to get this. And you have to train all ways because that's when you get good. And we're doing that. So one is you're going, well, if you're not moving, then your velocity is 0, boom. And it stays 0. The other is this. On this graph, I've got X, my position at a time. That's the points. On this graph, I've got change in X over change in time. And I'll go ahead and put earlier to later because I don't want to shortcut that. What is that? What's the slope on this graph mean? What's that mean? What would the units be? What's the units of displacement?
Meters per second.
Meters per second. So what is this definition of? What does this give you?
Velocity?
Yeah. And this would be average velocity, unless it stays the same, then it's the same. So that's velocity, right? So the slope, what's the slope on this curve? What's that slope?
Flat.
It's flat. Flat is the right word. It's flat. And so, in other words, there's no slope, right? If you're walking along here, this is nice, it's flat, you know, but this is time, but that's flat. I'd say that's a straight line. I'd call that a flat line. People are a little sloppy with those words too. That's a straight line, flat line. We're gonna do a lot of straight lines and flat lines because there's enough to learn. Like I said, we'll just keep it, work our way up. So that means that the slope is 0. That means my velocity is 0. I knew that, but I'm just thinking about it another way. So my graph, it doesn't matter where you are, your graph's gonna be here. V equals 0. And it'll be constant. Your position is constant. Your velocity is 0. If your velocity is not changing, what's your acceleration? Are you speeding up or slowing down? Am I speeding up or slowing down?
Neither. 0.
Okay. Remember, we have to translate. Now, one more little bit, because you can get a lot. These exercises, power through it. It'll start, it's fun when it starts making sense. Initially, though, I hate that initial part where you're just totally lost. Like, oh, no idea. That's why I like the preview. If I go from here to here, or whatever, if I go from here to here, there's a graphical area. Or I could go from whatever, here to here. There's a graphical area. So a math class might go, okay, what is that? And you'd say, oh, it's this times the change in that. It's X times the change in T. It'd be like a box. This is the change in time, and this would be the X value. If I look at the units, that's meters times seconds. Now, I don't know if you remember this from chapter 2, but we keep doing it, it'll start sinking in. I don't know what that means. It's useless. Math, you can calculate it, but what are you calculating? I don't care. We're wasting your time. Now, some math professors know more physics than others. We have Carol Stanton, who knows a lot of physics. Sherry Sharufa, who actually did engineering too. I mean, it's been a while, so she might have forgotten some of that stuff. You can't hold her to, but she's done that, right? Terrell Mead, you know, a lot of our folks do, and that's good. But you can do math and not know your physics. So to calculate the area there is just a waste of time. Okay. Let's take it up a notch. Let's go from a flat line to a straight line. Remember, through training, these are the 3 things you're going to look at. What do they mean? I look at what they mean. I look at the units. Oh, that's useless. It's going to be very useful here and here. Not useful here. Okay. Let's do the exercises. Okay. Really, we take a lot more time on this, even, but this is more than you usually have in a class. So let's do this. Okay, I got it. Lots of ways to think about it. T. I'll put the units so I know what I'm talking about. Maybe put some marks. Oops. Okay. The only way to learn music is to play it, but you should pause and think about it too. Same with physics. All right. Suppose I tell you that you have a constant velocity, not zero, but some positive number. Two meters per second. And it stays 2 meters per second the whole time. Are you going to be standing in one place? No. What does that tell you about this? How do you see the velocity on this curve? You got three choices: points, slope, or area.
Slope.
Slope. So that means that the slope here is 2. That means you're going to go up 2 for every 1. Now watch, little things, little things. It's cool, it's cool. That means if I start at 0, then I'm going to increase 2 meters every second. Every second, I'm going to go up 2 over 1, up 2 over 1. But you don't have to start there. You could start here. See, from this, I don't know my position. I know if I start here, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. 1. You can do it. Yeah. Notice that if I drew it correctly, these would have the same slope. Or I could start here. Doesn't matter where you start. All these have a slope of +2. If you call that 0, that's fine. I just walk past the place you called 0. Or I start at 0. Or I start up here. This is the slope of that. If you just memorize the words, there's no way. This is the slope of that. What's the slope of this line? Somebody hasn't said anything? What is it?
2 meters a second.
Now it's the slope of that line. The value is 2 meters per second. What's the slope of that line?
Flat.
Flat. 0. In other words, if you're not changing your velocity, you're not accelerating. So you can see that you need some practice with this. When an exam comes, some of the stuff, this usually shows up a bit. And if you can do it fast, you can think about the other stuff. But you're not training just for your physics class, because this is an important part of the science. Now, if I have a negative value, that means my slope is down. But if it stays negative, then it's still 0 acceleration. And finally, so do the exercises, do best. Okay. On Canvas, I added something to the sidebar, and it says discussion. You can go to that discussion and post a question, or where you want to actually have a discussion with people. And so you can answer each other's questions, and by doing that, that'll help solidify it for you. So you can make up your own questions on that discussion when you click that discussion. You can create that free zoom.us account and have a Zoom session where you share screens. It really helps you learn faster. I got a big story about that, but I won't tell you, because I want to get on with something else. But it's huge if you do it right. You want to make sure that you're not just nodding your head and Eric's telling you all the answers. Like, okay, well, I didn't learn it, but Eric did. Okay. The graph can make you imagine the motion, or the motion can make you create the graph. And you can tie it to the equations. And you can do this. You will struggle if you're human at first. Positive struggle. Okay, check this out. I'll do it this way. Draw this. I kind of sketched this for you last time. I'm going to show you two graphs. I'm going to go 0 here for the first second. I'm going to go up 1, 2, 3, 4 in 2 seconds. Then I'm going to go down 4 in 1 second. It's supposed to be straight. And I'm going to go down 4 more in 1 more second. 1, 2, roughly, right, in 1 second. And then I'm going to go flat for, I don't know, another second. I'm going to draw that exact same graph over here. And this is a super good challenge, puzzle. Go over here. I got 1, 2, 3, 4, 5, really 6. 1, 2, 3, 4, 5, 6. I'm going to go up 1, 2, 3, 4, and down 1, 2, 3, 4. I'm going to make the same shape graph, flat for 1. For 2 seconds, I'll go up 1, 2, 3, 4 over 2. I'll come down 4, but I'll do it in 1 second. I'll go down 4 more in 1 second. And then I'll go flat for a second. You can do this stuff. You're ready for the exam in physics. It's not going to get harder. You can master this. But initially, it'll be slow. I'm just going to answer the question. Take a moment and ask yourself, do these two graphs describe the same motion? Just think about it yourself. Next, when we were describing one motion, did the graphs look the same or different? And finally, I know this is fast, you got to exercise. Let's see what this one tells me. This is super good. This one says that when I start my stopwatch, I'm standing here. This is not space. You're not moving this way. This is time. You're moving along one dimension, and the graph spreads it out in time. And I stay there until here. So I'm standing still. My velocity is 0. So I'm going to do that 1, 2, 3, 4, 5, 6. time 1, time 2, time 3 is a little more, times 4, oops, is right here, 5 and 6. Okay, check this out. Watch this. From 2 to 3, V average 2 to 3 is equal to delta X 2 to 3 over delta T 2 to 3. I can look at this. I go up 1, 2, 3, 4. So that's equal to plus 4 meters in 2 seconds, or 2 meters per second in the positive direction. I can calculate that. Eventually you build that speed. It's just like you're familiar. You're that close. Keep pushing yourself. Now over here, from 3 to 4, I go minus 4 in 1 second. So my average velocity is minus 4. And here I go minus 4 in another second. So my velocity here is minus 4. And then 0 again. Crossing the axis just means I crossed wherever you said was 0. You got to think it through yourself. Believe me, when our lab guy is a good guitarist and show me something. I got to think through that myself. I didn't follow that. What does this say? Something very different. This says I start at 0 velocity. I don't know where I start. You can start wherever, but wherever you are, you're at 0 velocity. Now it says I'm going faster and faster and faster. So this is slow in the positive. This is V equals 0. And this is fast in the positive. I'm going faster and faster and faster. I don't have, here I have the same velocity. Here I'm going fast, because that's what this means. I'm going faster and faster and faster. And then I turn around. I can't do it instantly like this graph says. And now look at this. Okay, guys, follow this. You can do it. I'm going in some direction called plus. Say that way. And I start out 0, and I go faster and faster and faster and faster and faster and faster. And then I'm still going in the plus direction. This confuses people, understandably. I'm going in the plus, it's still positive. I'm still going this way. I'm just going slower and slower and slower until I stop. And now I go in the negative direction, faster and faster and faster this way. So this is slow negative, and this is fast negative. I'm going faster and faster, faster. Then I keep going the same direction, slower and slower, until I stop V equals 0 for an instant. I got to bounce off the wall, because usually I'll stop, hang out for a minute, and then whatever. And then I go faster and faster the other way. So it's a challenge to read these, but you know the tool, and if you drill yourself, look at the points, look at the units, the slope, what does it mean with the units, and the graphical area. The last little bit here, real quick, is that I've got a graphical area here. This is kind of a funky triangle. I would break this into 2 triangles, half of this times that, and then here's another triangle. And the area on this graph would be V times change in T. And I sum that up. Now, if it's a triangle, I'm going to have to do 1/2, etc. So be a little careful with that. But what are those units? Basically, what does that mean? This means meters per second times second. That's a meter. This is not X. It's delta X because you did it over some time. You weren't at one position, you were changing positions. And so this is a delta X displacement here of positive, meaning, because why? Because you were going in the positive direction. I'm going faster and faster and slower, so I'm still going in the positive direction. I'm still displacing that way. Now I'm going the other way. Now my displacement's negative. I'm going back the other way, faster and faster. There's my delta X over there. And you can calculate it with simple area of a triangle and area of a rectangle. Kind of fast. Go through it slowly. Yeah, working with others will increase your speed and your retention. And we got 3 weeks. Whatever you put in, you'll get out. And maybe you can't, whatever, then you can still feel good about it because you're still going to be helped by going through some of this. But whatever, the more you put in, the more you'll get out. You may not have the stuff mastered, but go forward because when you come back to it, it'll make more sense. Chapter 4 is about algebra, taking these equations and manipulating them and seeing some really messy, ugly looking algebra. And the more you play it on paper, the better you'll get. And then the next chapter, 5, is applying basic trigonometry, which I review. And if you do those drills, you'll have everything you need, everything you need. And then applying that to vectors, velocity, acceleration, and so on. And there are lots of vectors. If we probably won't get to it, I'm for sure we won't, chapter 7, but if you can do that before the semester starts, you're going to be happy that you did. I guarantee you'll be happy you did. And yes, you'll learn new physics as you go through the course. It will take you time. Don't plan on it being easy, but you'll be in the game. You know how to do physics. And some people will get through the whole course and never learn that. And that's sad. But if you learn something, when you go, I don't care, physiology, engineering, anything, oceanography, whatever it is, this stuff comes up. Graphs come up and physics comes up. And it's not so bad if you learn it. MCAT, all that stuff. Surgery. If you're going to be a surgeon, you got to play video games, I'm told. You got to be able to manipulate the thing. Really, people tell me that are surgeons, like at UCSF and whatever. It's like, okay, well, I would suck. Anyway, any questions? Feel positive, I hope, and effort's your responsibility and mine if I want to get any good at guitar. Helped. Was that helpful, or would you rather have that we did breakout session?
That was helpful.
I'd rather watch the board.
Yeah, me too.
I kind of like this more, especially if you have a question asked.
And I'm with you, and I asked that because, we get into these groups and people talk about education, and some people get doctorates in education. They talk about all these ways of, and yeah, it's great to work together, but some of them don't understand STEM. Like, we actually got to learn this stuff, and so it can be helpful to watch someone do this. I think what I'm going to do is make some maybe videos, more videos where I do some examples, but good. Yeah, because I'm open, and I think that working in breakout is useful because you kind of struggle with things, but it is, of course, slower. If I did a lecture and I just completely left you behind and didn't care about you, it's like, I'm doing my own thing. What's wrong with you? That's a problem. And that's usually what happens in college physics classes. But
Professor, is there any way we can access these recordings later if we want to review?
I have to figure that out. They record as an MP4.
Okay.
But Canvas doesn't have enough space for me to upload them.
Is there like a link where we can access it for like a temporary amount of time or something like that?
I like that idea. I'm glad you asked that. Because it's something I've thought about.
I've seen it in the pre-algebra class that the instructor there was able to have each recorded segment in there that you can go and look at later, the recordings.
Did you look at it in the cloud or?
think it was on their server, right? Like,
Yeah,
Zoom.
something like that. I'll try to figure that out, or you can send me an email, tell me how to do that. One way to do it is for me to get it onto YouTube, because I've already got the YouTube channel, and then I could link that. It's not a bad idea, because then I can put that into your module and just boom, it's there, just like my YouTube. So I've got my YouTube videos and there, but when I did those, first it takes a lot of time. So I just wanted to get the fundamentals there. And I always try to improve that, but I didn't do as many examples. So thank you. And feel free to email me. You can email me day and night. Where's that video? Where's that video? And I'll try to get that to you.
Okay, thank you.
Yeah,
Thanks.
thanks.
All right, excellent.
All right, get her done.
All right, thank you, Professor.
All
All
right,
right, thanks.
see you guys. Thanks, that was fun.